What if one of the most brilliant minds of the modern world died with more secrets than inventions? What if the man who helped electrify civilization was not only building motors, transmitters, and wireless machines, but was also searching for hidden forces inside nature itself? Forces moving silently through the air, forces buried inside vibration, forces sleeping in frequency, magnetism, resonance, and the invisible architecture of the Earth. This is the strange and haunting story of Nikola Tesla, the Serbian-American inventor, electrical engineer, mechanical engineer, visionary, and one of the most misunderstood figures in scientific history. To some, Tesla was a genius who saw the future before the world was ready for it. To others, he was an eccentric old man chasing impossible dreams. And to those who study the darker corners of his life, Tesla remains something even more mysterious. A man who may have taken certain ideas to the edge of science, secrecy, and myth. In his final years, long after the public celebrations had faded, Tesla continued to work alone. His laboratory was gone, his fortune was gone, many of his supporters had vanished, but his mind remained restless. He still imagined machines that could transmit energy without wires. He still believed the Earth itself could behave like a gigantic electrical system. He still looked at lightning, radio waves, cosmic rays, and mechanical vibration as if they were pieces of one hidden code. And yet, many of his projects were never completed. Some collapsed because of financial ruin. Some were rejected because society thought they were too strange. Some disappeared into private papers, broken memories, or locked government files. After Tesla died in 1943, the legend only grew. Stories began to spread that some of his most powerful ideas had been lost, hidden, confiscated, or deliberately ignored. Some stories are based on historical documents, some are exaggerated, some are speculation, and some drift into the realm of mystery, where science and myth are almost impossible to separate. But the question remains powerful. What exactly was Tesla trying to build? And could some of his abandoned inventions have opened a completely different chapter in the history of science and technology? To understand that question, we must begin with one of the most feared and mysterious ideas ever associated with his name, a weapon so strange that newspapers called it a death beam, a machine Tesla himself claimed could end war by making war impossible. And if even a fraction of what he imagined was true, then the world may have come closer than we realize to a new kind of power not powered by bullets, bombs, or fire, but by particles, electricity, and the invisible force of acceleration. By the early 1930s, Nikola Tesla was an old man. His hair had turned white. His body had grown fragile. The world that once celebrated him had largely moved on. But Tesla's mind was still living in the future. Around him, the atmosphere of the world was changing. Europe was becoming unstable. The shadow of war was spreading across nations. Aircraft were becoming faster, deadlier, and more important to military strategy. The nightmare of cities being bombed from the sky was no longer science fiction. It was becoming a political and military reality. Tesla watched this with deep concern. He was not a man who loved war. In fact, much of what he claimed to design in his later years was described not as a tool of conquest, but as a tool of prevention, something so powerful that no nation would dare begin a war. This was the idea behind one of his most controversial concepts, a directed energy weapon, sometimes called the death ray, though Tesla himself reportedly disliked that name. He preferred to describe it as a defensive system, a shield, a wall of force, a scientific barrier so advanced that armies, aircraft, and invading forces would become useless. In 1934, at the age of 78, Tesla spoke to reporters about a new kind of weapon. According to newspaper accounts at the time, he claimed he was working on a particle beam device that could bring down thousands of enemy aircraft from hundreds of miles away. The idea shocked the public. At a time when nations feared aerial bombardment, the possibility of a machine that could destroy incoming aircraft before they reached a city sounded both terrifying and seductive. Imagine the world of the 1930s. Governments were frightened, militaries were modernizing, and ordinary citizens were beginning to understand that the next war might not be fought only on battlefields. It might come from the sky. Into that fear stepped Tesla, with a vision that sounded like it had fallen out of another century. Not a cannon, not a bomb, not a chemical weapon, but a beam. A focused stream of energy or particles, accelerated by electricity and directed with precision. According to descriptions attributed to Tesla, the system would require enormous electrical power. It would involve specialized apparatuses capable of generating, concentrating, and projecting energy across great distances. In some retellings, the device was imagined as a series of towers placed along coastlines and borders. creating an invisible defensive barrier around a nation. In other accounts, smaller versions could be installed on battleships. The concept was dramatic. A country protected not by walls of stone, but by invisible walls of energy. Tesla imagined that if every nation possessed such a defensive shield, invasion would become impossible. War would lose its purpose. No enemy army could cross the border. No hostile aircraft could survive the approach. In Tesla's mind, the invention was not meant to create destruction for its own sake. It was meant to end destruction by making aggression obsolete. But this is where the mystery deepens. Tesla did not have the money to build a full working system. He tried to secure financial support from powerful interests. He contacted governments. He reportedly offered the concept to multiple nations. He searched for patrons who would understand the scale of what he was proposing. But to many officials, the idea sounded too ambitious, too unproven, and perhaps too dangerous. The United States government was skeptical. Other governments listened, but did not fully commit. Tesla's dream of building a prototype never became reality, at least not publicly. According to some accounts, he attempted to sell or present portions of the design to foreign governments, including the Soviet Union and the British government. These stories remain surrounded by uncertainty, but they helped create the legend that Tesla's final inventions were not merely forgotten, but pursued in secret. In 1937, Tesla claimed that his room had been broken into and his papers disturbed. He suggested that spies had been searching for details of his weapon, but Tesla also claimed that the most important parts were not written down. They were stored in his mind. That single idea has haunted Tesla's story ever since, because when he died in 1943, whatever remained in that extraordinary mind disappeared with him, and whether the death beam was a practical weapon, an unfinished theoretical idea, or the dream of a genius whose imagination had outpaced engineering reality, it became one of the most powerful legends in the history of invention. Some later writers have connected Tesla's death beam to the development of directed energy weapons or even laser technology. That connection should be treated carefully. Modern lasers emerged from many scientific developments that came after Tesla, especially in quantum theory and optical physics. But Tesla's obsession with directed energy was real. His belief that electricity could be focused, transmitted, and weaponized was real. And his dream of using overwhelming power as a deterrent against war foreshadowed one of the defining ideas of the modern age, the terrifying belief that peace could be preserved by the existence of weapons too powerful to use. But Tesla's imagination was not limited to destructive energy. Long before drones, remote-control vehicles, and robotic warfare, he had already demonstrated another machine that seemed impossible to the public. A small boat, floating on water, moving without a visible operator, answering commands from the shore. And to the stunned audience watching it, the machine did not look like technology. It looked alive. In 1898, decades before the modern age of drones, wireless devices, smart machines, and remote-controlled vehicles, Nikola Tesla stood before an audience at Madison Square Garden in New York City. The event was an electrical exhibition, a place where inventors displayed the wonders of a new technological age. Electricity was still magical to many people. A light bulb turning on in a room could feel like a miracle. A motor spinning without steam could feel like sorcery. Radio itself was still mysterious, an invisible messenger moving through the air, passing through walls, unseen and almost impossible for ordinary people to imagine. Then Tesla brought out a small boat. It had no crew, no visible cable, no hand guiding it, no hidden oarsman. And yet, when Tesla sent commands, the boat responded. It moved across the water. Its propeller started. Its rudder turned. Its lights flashed. To a modern viewer, this may sound ordinary. Remote control is everywhere now. We guide toys, aircraft, cameras, military drones, garage doors, and spacecraft with signals we cannot see. But in 1898, this was astonishing. The crowd did not understand what they were witnessing. Some thought Tesla was using hidden wires. Others suspected trickery. Some believed the boat might contain a trained animal or a small person hidden inside. Tesla understood the psychological power of the moment. Instead of immediately explaining everything, he allowed the mystery to deepen. He suggested, playfully, that the boat could respond to commands almost as if it had intelligence. When someone asked it a question, the cube root of 64, the boat flashed its lights 4 times. 4. The correct answer. The audience was stunned. Of course, the boat was not thinking. It was obeying radio-controlled electrical signals transmitted by Tesla from a distance. But that demonstration revealed something profound. Tesla was not merely building a toy. He was showing the world the first glimpse of teleautomation machines controlled wirelessly from afar. He had imagined a future in which machines could be guided without physical contact, vehicles could move without a human on board, devices could respond across distance. War, industry, exploration, and communication could all be transformed by invisible signals. Tesla's patent for this invention, U.S. Patent No. 613,809, described a method of controlling moving vessels or vehicles by wireless electrical impulses. Today, that concept lies behind technologies that define modern civilization: remote-controlled systems, robotics, drones, autonomous vehicles, wireless command networks, even space probes that receive instructions across millions of miles. But when Tesla first demonstrated it, the world did not fully grasp its importance. This happened repeatedly throughout his life. Tesla would reveal a concept before society had the language to understand it. People saw spectacle. Tesla saw infrastructure. People saw a strange boat. Tesla saw the future of machines. And yet, even this was only one corner of his imagination, because for Tesla, everything in nature seemed connected by vibration. A motor vibrated. A bridge vibrated. The earth vibrated. Electric current oscillated. Radio waves oscillated. The human nervous system itself transmitted electrical signals. To Tesla, vibration was not simply movement. It was a key to hidden order. And according to one of the most famous legends about him, he once built a machine so sensitive to resonance that it shook a building and perhaps, if pushed further, could have shaken much more. This story has been repeated for generations. A small device, a mechanical oscillator, a strange trembling in the streets of New York, and Tesla standing in his laboratory, calmly stopping the machine before the vibration grew out of control. Was it fact? Was it exaggeration? Or was it a glimpse into a real principle that engineers still respect today? To understand it, we must look into the invisible power of resonance. In 1893, Tesla received a patent connected to a mechanical oscillator, a steam-powered device designed to vibrate at high speed. The purpose was not originally to destroy anything. Tesla was experimenting with oscillation, mechanical movement, and the possibility of converting vibration into useful power. But years later, a dramatic story emerged. According to Tesla's own later descriptions, while testing a small oscillator in his New York laboratory, the device began to vibrate in harmony with the building. At first, the movement may have seemed harmless, then the vibration grew stronger. Objects began to shake. The floor trembled. People nearby felt the disturbance. Police and emergency responders supposedly arrived at the scene, confused by what seemed like an earthquake in the middle of the city. Tesla, according to the story, grabbed a hammer and disabled the machine. Then, when questioned, he acted as if he had no idea what had happened. This became the legend of Tesla's earthquake machine. In some versions, Tesla claimed that with the right frequency, a small oscillator could bring down large structures, even something as massive as the Empire State Building. Now, this claim should be treated carefully. There is no solid evidence that Tesla built a machine capable of producing true earthquakes or destroying skyscrapers. The legend has grown over time, and many details are impossible to verify. But the scientific principle behind the story is real. Resonance is real. Every object has natural frequencies at which it vibrates more easily. A swing moves higher when pushed at the right rhythm. A glass can shatter if exposed to the right sound at the right intensity. Bridges, buildings, engines, and aircraft must all be designed with resonance in mind, because vibration at the wrong frequency can become dangerous. Tesla understood this deeply. He saw that energy did not always need brute force. Sometimes, energy needed timing, rhythm, frequency, precision. In that sense, the earthquake machine legend is more than a story about destruction. It reflects Tesla's broader worldview, that nature is governed by invisible patterns, and that the right frequency applied in the right way can unlock astonishing effects. This is one of the reasons Tesla's image remains so powerful. He did not look at the world as a collection of separate machines. He saw systems, waves, fields, harmonics. He imagined the Earth itself as something that could be electrically stimulated, like a vast conductor suspended in space. He believed energy could be transmitted through air, ground, and atmosphere. He believed machines could communicate across distance, and he believed the invisible world was not empty. It was full of structure, full of motion, full of power. But Tesla's fascination with the unseen did not stop at electricity or mechanical vibration. At times, he also explored the mysterious relationship between thought, vision, and the human mind. Long before brain scanners, neural imaging, artificial intelligence, and attempts to reconstruct mental images from brain activity, Tesla imagined a machine that could capture thoughts, not metaphorically, literally, a device that might one day photograph the images inside the mind. It sounds impossible, but for Tesla, impossibility was often just a word used by those who had not yet found the right mechanism. Tesla's imagination often moved toward the border between science and philosophy. He was not only interested in machines outside the body, he was fascinated by the mind itself. According to reports from the 1930s, Tesla spoke about the possibility of photographing thought. He believed that images formed in the mind might somehow be reflected in the retina and could potentially be captured, amplified, or projected. To modern science, this specific explanation is not correct in the way Tesla imagined it. Thoughts are not simply pictures printed onto the retina from within. The brain constructs images through complex neural activity, memory, perception, and electrical signaling. But the deeper question Tesla was asking remains extraordinary. Could the invisible activity of the mind ever be translated into visible images? Today, scientists have made early attempts to reconstruct images from brain signals using MRI, neural decoding, and artificial intelligence. These experiments are still limited and far from mind-reading in the dramatic sense, but they show that Tesla's instinct was pointed toward a future that would eventually become real in another form. Once again, Tesla imagined a possibility before the tools existed to properly test it. Some biographical accounts suggest Tesla experienced unusually vivid mental imagery from childhood. He could visualize machines in his mind with extraordinary clarity. He claimed he could build, test, and refine inventions mentally before creating physical models. If true, this ability may have shaped his belief that thought was almost tangible, that a mental image might be treated like a physical phenomenon, something governed by energy, optics, and electrical patterns. For Tesla, the boundary between the material and the invisible was never as solid as it appeared. Light was vibration. Sound was vibration. Electricity was oscillation. Perhaps in his mind, thought itself was part of the same grand system, a signal, a pattern, a hidden electrical event, and if a signal exists, maybe it can be detected. If it can be detected, maybe it can be amplified. If it can be amplified, maybe it can be displayed. This is the kind of reasoning that made Tesla both brilliant and controversial. He reached toward truths long before the proper instruments existed. Sometimes he was visionary, sometimes he was mistaken, sometimes he was both at once. But his imagination did not remain on Earth. Tesla was fascinated by flight. As a child, he dreamed of movement through the air. As an inventor, he watched aviation emerge as one of the great technological frontiers of the 20th century. And after the failure of his great wireless power project at Wardenclyffe, he turned some of his attention toward aircraft. But Tesla did not imagine ordinary aircraft. He imagined fast aircraft, electric aircraft, machines that could cross oceans in hours, vehicles that might not need to carry fuel in the conventional way. To understand that vision, we must return to the dream that haunted Tesla for much of his life: wireless energy. Tesla believed that the future of power should not be chained to wires. To him, wires were a primitive stage, useful but incomplete. He imagined a world where energy could be transmitted across distance, where power stations could send electricity through the earth and atmosphere, where cities, homes, machines, ships, and perhaps aircraft could receive power without physical connection. It was a dream both beautiful and dangerous. Beautiful because it promised a civilization liberated from fuel scarcity and transmission limits. Dangerous because it challenged existing business models, financial interests, and the basic structure of electrical industry. After the collapse of his Wardenclyffe project, Tesla's dream of a global wireless transmission system was wounded, but not dead. In 1919, Tesla reportedly discussed concepts for high-speed electric aircraft. He imagined a machine that could travel from New York to London in only a few hours. According to the idea, such aircraft might draw energy from power stations rather than carrying all their fuel on board. To a modern audience, this sounds almost impossible. Even today, electric aviation faces major challenges: battery weight, energy density, range, infrastructure, and safety. Supersonic electric flight remains far beyond practical commercial use. But Tesla was not thinking only in terms of batteries. He was thinking in terms of wireless power. He imagined aircraft connected not by cables, but by fields, machines moving through the air while drawing energy from an invisible electrical network. The concept remains speculative. Tesla never built such a system. There is no evidence that his idea became practical in his lifetime. But as a vision, it reveals the scale of his ambition. He did not merely want to improve technology. He wanted to redesign the relationship between civilization and energy. In Tesla's world, nature was not a warehouse of fuel to be burned. Nature was a reservoir of motion, charge, vibration, pressure, and light. The question was not whether energy existed. The question was whether humanity understood how to receive it. This same belief shaped another strange and unsettling proposal attributed to him, the idea of creating artificial tidal waves through explosive or electromagnetic means at sea. According to some reports from the early 1900s, Tesla suggested that powerful forces could be used to generate waves capable of disabling enemy fleets. The idea sounds apocalyptic. A man-made tide rising against battleships, the ocean itself becoming a weapon. But like the death beam, the stated logic behind the concept was deterrence. If weapons became so devastating that no navy could survive them, then perhaps nations would hesitate before going to war. This way of thinking would become painfully familiar in the nuclear age. A weapon so destructive that its purpose is not use, but prevention. A technology whose existence becomes a warning. Tesla believed science could prevent war by making aggression irrational, yet history has shown that weapons do not always end conflict. Sometimes they create new fears, new races, and new dangers. And this is one of the tragic contradictions in Tesla's legacy. He dreamed of peace. But some of his ideas moved toward instruments of overwhelming force. He dreamed of free energy, but his financial life ended in failure. He dreamed of global communication, but others would receive the fame. To understand how a man with so many patents, so many discoveries, and so much vision could die poor and alone, we must enter one of the most painful chapters of his life, the rise and fall of Wardenclyffe. At the beginning of the 20th century, Nikola Tesla still believed he could change the world. He had already achieved fame through his work on alternating current. He had demonstrated wireless lighting, high-voltage experiments, radio-controlled machinery, and electrical phenomena that stunned audiences. He was not merely an inventor. He was a symbol of the electrical future. Then came Wardenclyffe. On Long Island, New York, Tesla began building a massive tower, a structure meant to become the heart of a global wireless communication and power system. To the public, it looked strange. To Tesla, it was a transmitter, a monument, a key, a machine designed to speak through the earth and sky. He convinced financier J.P. Morgan to provide funding, reportedly more than $150,000, a massive sum at the time. Tesla presented the project as a system for wireless communication, perhaps capable of sending messages across the globe. But Tesla's ambitions were larger. He wanted not only communication, he wanted power, wireless electrical power transmitted across the world. A planetary system. The idea was breathtaking. Imagine ships at sea receiving messages without cables, remote villages receiving electricity without power lines, factories, cities, and homes connected to a global energy network. A world where electricity moved through the planet like blood through a body. But there was a problem. Tesla's vision was expensive, very expensive, and as the tower rose, the money began to disappear. Tesla needed more funding. Morgan became skeptical. At the same time, another inventor was capturing the world's attention, Guglielmo Marconi. In December 1901, Marconi successfully transmitted a wireless signal across the Atlantic. Whether his system used ideas that overlapped with Tesla's patents became a matter of dispute. Tesla believed Marconi had used elements of his work, but public recognition shifted toward Marconi. Investors followed success. Tesla's Wardenclyffe project became harder to finance. Morgan refused further support. Workers were eventually dismissed. The tower stood unfinished, a giant skeleton of an unrealized future. By 1915, Wardenclyffe was facing foreclosure. In 1917, the tower was demolished. That demolition was more than the destruction of a structure. It was the symbolic collapse of Tesla's greatest dream. After Wardenclyffe, Tesla's public power declined. He continued to invent, propose, and imagine, but he never again commanded the same financial support. His later years became a mixture of brilliance, isolation, and struggle. There is another financial story often told about Tesla, his relationship with George Westinghouse. Tesla's alternating current patents had enormous value. Had he continued collecting royalties at scale, some believe he might have become unimaginably wealthy. But Westinghouse, who had backed AC power, faced severe financial pressure during the battle against Edison's direct current empire and related corporate forces. According to the popular version of the story, Tesla gave up or reduced his royalty claims to help Westinghouse survive. The details are debated by historians, but the emotional meaning of the story remains powerful. Tesla did not live like a man obsessed with money. He lived like a man obsessed with ideas, and that difference may have cost him everything. By the 1920s and 1930s, Tesla was still announcing concepts, still speaking of energy, still presenting visions of future technology. But the world no longer listened with the same confidence. Some saw him as a relic. Some saw him as a genius gone too far. Some saw him as a prophet whose time had passed. When he died in 1943 at the age of 86, he was living alone in a New York hotel room. He had become famous for feeding pigeons. His finances were exhausted. His health was failing. Yet even in poverty, his mind remained attached to a future he believed humanity had not yet earned. At his memorial, New York Mayor Fiorello LaGuardia honored him as a man whose achievements were immense and whose importance would grow with time. That prediction proved true. Tesla's fame did grow, but it grew in a strange way, not only through textbooks and engineering history, but through legends, lost notebooks, secret inventions, government seizures, alien signals, radio messages from other worlds, and perhaps the most dramatic myth of all, that after Tesla died, hidden forces rushed to collect what he had left behind. When Nikola Tesla died in January 1943, the United States was in the middle of World War II. This detail matters. Tesla was not just an old inventor passing away in peace. He was a man who had publicly claimed to possess designs for advanced weapons. He had discussed directed energy systems. He had contacted foreign governments. He had patents, notes, and technical papers connected to high-voltage electricity, wireless transmission, and unusual devices. So when he died, authorities became interested in his belongings. Historically, Tesla's papers and possessions were examined and handled by officials connected to the Office of Alien Property, because Tesla, despite living in America for decades, was born abroad. Over time, this real event became surrounded by rumor. Some claimed the FBI seized his papers. Some claimed government agents removed his most important notebooks. Some claimed secret weapons were hidden. Some claimed the death beam vanished into classified military research. The truth is less cinematic but still intriguing. Officials did examine his materials. Some items were later returned to Tesla's family and eventually became part of museum collections. But the popular imagination had already seized on a powerful image. Tesla dies alone. Agents arrivent. Boxes of papers disappear, and the greatest secrets of the electrical age vanish into silence. This is the kind of story that grows because it touches something people already suspect, that revolutionary ideas are not always welcomed, and that powerful knowledge often attracts powerful institutions. But the mystery does not end with government papers. Over the years, stories began circulating about a so-called lost diary of Nikola Tesla. In these stories, a writer or researcher supposedly acquired Tesla's secret journal at auction, only for authorities to later seize it. These claims should be treated as speculative. There is no widely accepted historical proof that such a diary contains the incredible revelations often attributed to it. The names and details vary in different versions. The story often appears in fringe literature, paranormal discussions, and mystery media. But the legend is worth examining because it reveals how Tesla's image changed after death. He was no longer just an inventor. He became a doorway, a figure people used to ask questions about hidden science, extraterrestrial intelligence, suppressed technology, and the limits of human knowledge. In one of the strangest claims, certain declassified or publicly discussed documents have been interpreted by some as suggesting that Tesla was connected to beings from Venus, even that he himself was from Venus. This is not accepted history. There is no credible evidence that Nikola Tesla was an extraterrestrial being, but the myth survives because Tesla himself often seemed, to admirers, almost otherworldly. He spoke many languages. He possessed an extraordinary memory. He imagined technologies decades ahead of public understanding. He worked with forces people could not see. To a society struggling to understand electricity, radio waves, and invisible energy, Tesla may have looked like a man who had received knowledge from somewhere beyond ordinary human experience. And Tesla did make one claim that helped fuel these legends. At the beginning of the 20th century, while experimenting with radio receivers, Tesla detected unusual signals. He wondered whether they might come from another planet, perhaps Mars. At that time, the idea of intelligent life on Mars was taken seriously by some scientists and the public. Mars was not yet known as the barren world we understand today. Telescopes revealed markings that some interpreted as canals. Popular imagination filled the red planet with possibility. So when Tesla heard strange, repetitive signals, He considered the possibility that they might be messages from another world. Today, scientists believe he may have detected natural radio phenomena, atmospheric signals, or perhaps signals from terrestrial sources. There is no proof that Tesla received messages from extraterrestrials, but his willingness to consider the possibility shows something important about his mind. Tesla did not assume humanity was the center of the universe. He looked upward. He listened. He believed the cosmos might be alive with signals, and for a man who devoted his life to invisible waves, the idea that intelligence could travel across space as electrical vibration was not absurd. It was a question, and Tesla lived inside questions. But some later stories went even darker. They claimed Tesla built a radio capable of hearing not just distant planets, but the dead, a machine that could tune into voices from another world, a receiver that picked up screams, whispers and sounds from what he allegedly believed might be hell. This is where history gives way to legend. But even legends can reveal the fear and wonder surrounding early radio. Imagine the year is 1901. Radio is still new. The air, once thought empty, is beginning to speak. Signals move through darkness. Voices and pulses appear where there should be silence. A receiver crackles in a lonely laboratory. Static rises. A pattern emerges. Then something that sounds almost like a voice. Today we understand that radio receivers can pick up all kinds of interference. Atmospheric noise, lightning, distant transmissions, electrical machinery, natural emissions, and random signal artifacts. The early radio environment was wild, poorly mapped, and full of strange phenomena, but to the pioneers of that era, it could feel as if the invisible world had awakened. According to paranormal legends, Tesla once built a receiver that captured frightening sounds, cries, low voices, and noises that seemed inhuman. Some versions claim he became disturbed by what he heard and wondered whether he had intercepted signals from a spiritual realm or another dimension. These stories are not established scientific history. They should be treated as folklore surrounding Tesla's life. But their emotional power is undeniable, because they connect two things Tesla understood better than almost anyone of his time. First, that the air is not empty. Second, that human senses reveal only a tiny fraction of reality. Most of the electromagnetic spectrum is invisible to us. Radio waves pass through our bodies without sensation. Magnetic fields surround us without sound. Cosmic particles move through space and matter. The Earth hums with electrical activity. Lightning strikes send waves around the planet. The ionosphere reflects radio signals back to the ground. In a very real scientific sense, we live inside an ocean of invisible motion. Tesla sensed this before the public did. He understood that the unseen world could be measured, amplified, transformed, and perhaps misunderstood. So when stories describe him listening to mysterious sounds in a dark laboratory, they capture something symbolic, even if the literal claims are doubtful. Tesla was listening to the hidden universe. He was tuning machines to frequencies beyond ordinary perception. He was asking whether nature carried messages humanity had not yet learned to decode. This is why Tesla continues to fascinate people more than a century later. He stands at the boundary between proven science and impossible possibility. He helped build real technology, but he also inspired myths large enough to surround the entire modern age. And one of the most important real conflicts in Tesla's life was not with aliens, spirits, or secret agencies. It was with another inventor, a man far more practical, far more business-minded, far more connected to industry, Thomas Edison. Their conflict became known as the War of the Currents, and in that battle the future of electricity itself was at stake. In the late 19th century, electricity was not yet the universal power source we know today. It was a frontier. Cities were dark at night. Factories relied heavily on steam. Homes were lit by candles, gas lamps, or oil. Then electric light began to spread, and the world changed. Thomas Edison played a major role in that transformation. He improved practical incandescent lighting and built systems to generate and distribute electrical power. His company helped bring electric lighting into public life. But Edison's system was based on direct current, or DC. Direct current flows in one direction. It can be useful, stable, and practical at short distances. But in the early electrical grid, DC had major limitations. It was difficult to transmit efficiently over long distances without losing power. It required generating stations close to customers. It demanded large amounts of copper wiring and expensive infrastructure. Then came alternating current, or AC. Alternating current changes direction repeatedly. With transformers, AC voltage can be stepped up for long-distance transmission and stepped down for safe local use. This made it far more practical for building large electrical grids. Tesla's work on AC motors and polyphase systems became central to the rise of alternating current. George Westinghouse recognized the importance of Tesla's ideas and supported their development. This created a direct challenge to Edison's electrical empire. What followed was not merely a technical debate. It became a public battle, a war of systems, a war of money, a war of fear. Edison and his allies attacked AC as dangerous. They emphasized its risks and associated it with electrocution. Public demonstrations were staged to show the dangers of alternating current. Animals were killed in demonstrations intended to frighten the public. The electric chair emerged in this same atmosphere of fear surrounding high-voltage electricity. It was a brutal campaign, but AC had one advantage that propaganda could not erase. It worked. It could send power farther. It could support larger systems. It could scale. And as cities grew, factories expanded, and demand increased. The practical advantages of alternating current became impossible to ignore. By the 1890s, AC was winning. Westinghouse and Tesla's system gained major credibility, especially after successful large-scale projects such as the use of Niagara Falls power. Edison eventually stepped away from direct involvement in the electric power business, and the war of the currents effectively ended with alternating current becoming the foundation of modern electrical distribution. In this sense, Tesla won one of the most important technological battles in history, but victory did not bring him lasting wealth. It did not protect him from obscurity, and it did not make him more powerful than Edison in public memory. Edison was a master organizer, promoter, and industrial strategist. He created research teams, managed business interests, acquired and improved technologies, and built a system for turning invention into commercial power. Tesla was different. He was intensely individual. He carried entire machines in his imagination. He could visualize mechanisms before building them. He pursued elegant principles rather than only marketable products. Edison searched by experiment, trial, and persistence. Tesla searched through theory, visualization, and intuition. Both men changed the world, but they represented two different kinds of genius. Edison was the architect of practical invention as industry. Tesla was the prophet of electrical possibility, and this difference shaped their legacies. Edison accumulated more than 1,000 patents. Tesla held fewer, often estimated at around 300 across various countries, though counts vary depending on classification. But numbers alone do not settle greatness. Some of Edison's inventions were improvements, commercial refinements, or the result of teams working under his direction. Many of Tesla's ideas were foundational, but some remained unfinished, underfunded, or too far ahead of available technology. Edison's genius fit the age. Tesla's genius often exceeded it, and that is why Tesla's story feels so tragic. He helped reveal the electrical architecture of the modern world, yet died before that world fully understood him. He imagined wireless communication before wireless civilization. He imagined remote machines before robotics. He imagined global power before the age of planetary networks. And he imagined invisible forces as the true machinery of nature. But Tesla is not the only subject of this larger story, because the same age that rediscovered Tesla also became obsessed with another kind of hidden power, not electricity but materials, not wires but structures, not motors but matter itself. And among the strangest materials ever created, one stands out as almost unreal, a solid that is mostly empty space, a substance lighter than almost anything human hands had ever made, a material that looks like frozen smoke, aerogel. Human civilization has always changed when it discovers new materials. Stone gave us monuments, bronze gave us weapons and tools, iron gave us empires, steel gave us skyscrapers, railroads, bridges, and machines, silicon gave us computers, carbon fiber gave us lightness and strength, and in the modern search for materials that are lighter, stronger, cheaper, more insulating, and more efficient, one substance has captured the imagination like few others: aerogel. It has been called frozen smoke, blue smoke, solid air, a ghost material. It appears almost impossible, a solid so light that a piece can rest on a flower, yet strong enough in certain forms to support many times its own weight. It is mostly empty space. In some forms, more than 99% of its volume can be air, and yet it is not a gas. It is a solid. This strange material began with a scientific challenge in the late 1920s. According to the classic story, American chemist Samuel Kistler made a wager with a colleague. The question was whether the liquid inside a gel could be replaced with gas without causing the gel's solid structure to collapse. Most people would assume no. A gel seems to depend on liquid. Remove the liquid, and the structure should shrink, crack, or fall apart. But Kistler believed otherwise. He wondered whether the internal network of a gel could remain intact if the liquid were carefully removed under special conditions. After many experiments, failures, and refinements, he succeeded. In 1931, Kistler published his work on coherent expanded aerogels and jellies in the scientific journal Nature. The result was extraordinary. He had created a gel in which the liquid component had been replaced by gas while the solid structure remained. In simple terms, imagine a wet sponge. If you let the water evaporate normally, the sponge may dry, but a gel at microscopic scale is much more delicate. Its tiny internal structure can collapse under surface tension as liquid evaporates. Kistler's solution involved a more careful process, bringing the liquid inside the gel to a critical state where the distinction between liquid and gas disappears, then removing it without the violent forces that would destroy the structure. What remained was a fragile, porous solid filled with air, a material that seemed to violate intuition. It was solid but barely there. It had form but almost no mass. It was matter arranged like a whisper. The first aerogels were often made from silica. Because of the way light scatters through their tiny pores, silica aerogels can appear faintly blue, almost like a piece of sky trapped in the hand. This blue color is not magic. It is connected to scattering, similar in spirit to why the sky appears blue. Shorter wavelengths of light scatter more strongly than longer wavelengths, and the human eye is especially sensitive to blue. But even when explained scientifically, aerogel still looks mysterious. It looks like a substance taken from a laboratory on another planet, and for decades aerogel remained difficult and expensive to produce. Kistler's original process required high temperatures and pressures. It was dangerous, slow, and costly. The material was fascinating, but not easy to industrialize. For a time, production expanded, including commercial efforts by companies such as Monsanto, but by the late 20th century, the process had faced financial and practical obstacles. Aerogel could have become a forgotten curiosity, but then new methods revived it. Researchers developed safer approaches using different chemical precursors and supercritical carbon dioxide drying. These improvements made production less hazardous and helped bring aerogel back into scientific and industrial use. And once aerogel returned, its possibilities seemed almost endless. Because its structure gave it properties unlike ordinary materials, it was extremely light, highly porous, a remarkable thermal insulator, capable of resisting heat transfer in ways that made it valuable for extreme environments. And few environments are more extreme than space. NASA and the aerospace industry became some of the most famous users of aerogel. Space exploration demands materials that can survive violent temperature changes, low pressure, high radiation, and severe weight limits. Every gram matters. Every layer of insulation matters. Every material must justify its existence. Aerogel, with its extraordinary lightness and insulation, became valuable in spacecraft, Mars missions, and scientific instruments. It has been used in insulation for Mars rovers, where equipment must survive brutal cold. It has been used in the Stardust mission to capture tiny particles from a comet without destroying them. This alone is astonishing. A material so delicate-looking that it can gently slow cosmic dust traveling at high speed. A net made of frozen smoke, catching fragments from deep space. Aerogel has also been explored for windows, protective layers, thermal barriers, and advanced insulation systems. Firefighters' clothing, building materials, industrial insulation, and specialized coatings have all drawn interest from aerogel technology. The reason is its structure. Heat travels in three main ways: conduction, convection, and radiation. Aerogel interferes strongly with conduction because there is very little solid material for heat to travel through. It reduces convection because its pores are so tiny that air movement is restricted. With added treatments, it can also reduce radiative heat transfer. This makes aerogel one of the most powerful insulating materials ever developed. But aerogel is not only one material. There are many kinds. Silica aerogel is the most famous, often pale blue and extremely light. It is sometimes called blue smoke or solid smoke. Carbon aerogel is darker, often black, and has very different properties. It can have a large surface area, high porosity, and useful electrical conductivity. These features make it interesting for supercapacitors, batteries, desalination systems, and energy storage. Metal oxide aerogels can be made from oxides of metals such as iron, aluminum, titanium, chromium, and others. They can be used as catalysts, in chemical reactions, in energetic materials research, and in advanced nanostructures. They can also appear in striking colors depending on their composition: deep green, blue, red, yellow, white, or other tones. Each type of aerogel is like a different answer to the same question. What happens when matter is engineered mostly out of emptiness? This question connects strangely with Tesla's worldview. Tesla believed the invisible was not empty. Aerogel proves that even emptiness can have structure. A material can be nearly all air and still behave like a solid. A machine can be controlled by waves no one sees. A city can be powered by currents moving through wires hidden underground. A message can cross an ocean as electromagnetic vibration. The modern world is built on invisible architecture: fields, signals, borders, frequencies, networks, structures too small or too subtle for human senses. Aerogel belongs to that world. It is not mystical, it is science. But it carries the same emotional shock as Tesla's greatest demonstrations. The realization that reality is stranger than ordinary perception suggests. Yet aerogel also has limitations. It can be fragile. It can be expensive. It can require complex manufacturing. Some forms are brittle and difficult to use in everyday products without reinforcement. Researchers have worked to solve these problems. In the early 2000s, Nikola Tesla and other scientists developed stronger polymer-reinforced aerogels, sometimes described in relation to cross-linked aerogel structures. These materials were designed to reduce brittleness and improve mechanical strength. The dream was to make aerogel not only light and insulating, but also tough, flexible, water-resistant, and more practical. Such advances open possibilities in aerospace, windows, protective clothing, vehicle systems, electrochemical devices, and thermal shields. Still, cost remains a barrier. Aerogel has not yet transformed every home, car, building, and machine in the way some early enthusiasts imagined, but its future remains powerful. As humanity searches for better insulation, greener energy systems, lighter vehicles, stronger batteries, and advanced space materials, aerogel may become increasingly important. And this brings us back to Tesla. Because Tesla's life and aerogel's story share a strange pattern. A discovery appears before the world is ready. People marvel at it. Then they hesitate. The technology remains expensive, misunderstood, or underused. Decades later, new generations rediscover its value. The future arrives slowly, and sometimes, the most important inventions spend years looking like impossibilities. Tesla once seemed impossible. Wireless control seemed impossible. Alternating current seemed dangerous and impractical to its critics. Global communication seemed like fantasy. Machines guided through invisible signals seemed like stage magic. Energy transmitted through the air seemed like madness. Yet pieces of that future became ordinary. Today we live surrounded by Tesla-like realities. We carry wireless devices in our pockets. We speak across continents. We control machines remotely. We depend on alternating current. We transmit invisible signals through homes, cities, oceans, and space. We build robots, drones, satellites, electric vehicles, and global communication networks. The invisible world that frightened and amazed people in Tesla's time has become the foundation of everyday life. But this also creates a haunting question. How many of Tesla's ideas were impossible, and how many were simply early? This is where his legend becomes difficult. It is easy to exaggerate Tesla. It is easy to turn him into a mythical figure who invented everything, knew everything, and was suppressed by everyone. That is not history. Tesla was brilliant, but not infallible. Some of his ideas were wrong. Some were incomplete. Some were impractical. Some were more poetic than technical. But it is also easy to underestimate him, to dismiss the strange old man, and forget how often his instincts pointed toward real futures. Remote control, wireless communication, electrical power systems, robotics, high-frequency currents, directed energy, global networks, energy as vibration, nature as a system of hidden forces. Tesla's greatness lies not only in what he built, but in what he made imaginable. He showed that the world is not limited to what the eye sees. He taught that power may move silently, that machines may respond across distance, that matter and energy are full of hidden behavior, that civilization advances when someone dares to ask questions others consider absurd. This is also why the darker legends cling to him: the alien stories, the secret diary, the death beam, the radio from another world, the government files, the lost notebooks. They endure because Tesla's real life already feels like the beginning of a myth. A young immigrant arrives in America with almost nothing. He works for Edison. He breaks away. He helps build alternating current. He lights the world. He dreams of wireless power. He builds a tower. The tower fails. He grows old. He speaks of weapons no one can verify. He dies alone. His papers are taken, and decades later the world slowly realizes that some of his impossible dreams were not dreams at all. That is the emotional core of the Tesla mystery. Not that every legend is true, but that the boundary between impossible and inevitable is often invisible until history crosses it. In the end, Nikola Tesla's story is not simply about inventions. It is about time. A genius can be born too early. A machine can appear before the market exists. A theory can be mocked before the instruments arrive. A material can be discovered before industry knows what to do with it. An idea can sleep for decades, waiting for civilization to catch up. Tesla believed many of his inventions were ahead of their time. Whether or not every statement attributed to him is accurate, that theme fits his life. He lived in an age of steam, copper, coal, and early electricity, but his mind moved toward wireless networks, remote machines, planetary power, advanced weapons, and invisible communication. He belonged to the 19th century by birth, to the 20th century by achievement, and perhaps to the 21st century by imagination. Aerogel follows a similar path, discovered in the early 20th century, difficult to produce, strange to understand, expensive to use, then rediscovered for space, energy, insulation, and advanced materials. Both Tesla and Aerogel remind us that the future does not always arrive loudly. Sometimes it appears as a strange demonstration in a public hall, a boat moving without wires, a tower rising on Long Island, a fragile block of blue smoke resting on a flower, a receiver crackling in the dark, a patent no one fully appreciates, a notebook no one can interpret, a failed experiment that becomes the seed of a future industry. And sometimes the future is ignored because it is too expensive, too strange, too dangerous, or too far ahead of human imagination. That is the warning inside this story. Humanity often misunderstands the invisible world. We trust what we can touch. We believe what fits the machines we already know. But the greatest transformations often come from forces we cannot see. Electric fields, magnetic fields, radio waves, resonance, atomic structures, microscopic pores, cosmic radiation, and the silent laws of energy moving through matter. Tesla spent his life trying to reveal those forces. Sometimes he succeeded. Sometimes he failed. Sometimes he crossed into speculation, but he never stopped looking. And perhaps that is why his name still feels charged with electricity. Because Tesla represents the kind of mind that refuses to accept the surface of reality. He looked at the earth and saw a conductor. He looked at the sky and saw a transmission medium. He looked at vibration and saw power. He looked at machines and saw intelligence waiting to be awakened. He looked at nature and saw not chaos, but design, a hidden geometry of energy. And whether we study his real patents or his surrounding legends, we are left with the same uneasy feeling. The world may still contain principles we have not fully understood. The future may already be hidden inside forgotten experiments. And some discoveries may be waiting, not because they are impossible, but because humanity has not yet learned how to listen. So what remains of Tesla's lost inventions? The death beam remains an unresolved legend, part historical claim, part speculative weapon, part symbol of science reaching toward dangerous power. The remote control boat remains a genuine milestone, a preview of robotics, drones, and wireless command systems. The earthquake machine remains a dramatic story built around the real physics of resonance. The thought camera remains an early dream of translating mental images into visible form, an idea modern neuroscience is only beginning to approach in a different way. The electric aircraft remains a vision still far beyond practical realization, but strangely relevant in an age searching for cleaner transportation and wireless systems. The artificial tidal wave remains a frightening example of Tesla's belief that science could deter war by making war too terrible to begin. Wardenclyffe remains the great ruin of his life, a tower that might have become a communication revolution, a wireless power experiment, or both. The Edison conflict remains one of the defining battles in technological history, a struggle not only between AC and DC, but between two different models of invention. And the myths of alien contact, secret diaries, and radios from beyond the grave remain exactly what they should be called: mysteries, legends, interpretations, and speculative stories that reveal the public's fascination with Tesla more than they prove hidden history. But perhaps the greatest Tesla mystery is not whether he spoke to other worlds. It is whether we have fully understood this one, because electricity was always here before humans named it. Magnetism was always here before humans measured it. Resonance was always here before humans feared it. The electromagnetic spectrum was always surrounding us before we built receivers. The structure of matter was always waiting before we created aerogel. Nature did not begin when humanity discovered it. It was already speaking. Tesla was one of the rare minds who tried to hear it, and that is why his story refuses to die. Not because every legend is true, not because every invention worked, not because every rumor deserves belief, but because Tesla's life asks a question that still burns in the modern age. What invisible powers are moving around us right now, waiting for the next mind brave enough to understand them? Maybe the greatest machines of the future will not be built from heavier engines, louder explosions, or larger factories. Maybe they will be built from silence, from fields, from frequency, from empty space given structure, from energy guided with precision, from materials as light as smoke, from signals moving through air, from the hidden laws Tesla spent his life chasing. And if that is true, then the story of Nikola Tesla is not finished. It is still unfolding. In every wireless signal, in every electric motor, in every spacecraft insulated against the cold of another world, in every laboratory where a scientist studies vibration, plasma, magnetism, or light, in every question that begins with the words, "What if?" Because the future does not arrive only through certainty. Sometimes it begins as a mystery. Sometimes it begins as a rejected theory. Sometimes it begins as a forgotten notebook. And sometimes it begins with one man standing alone in the electric dark, listening to the universe and wondering what else it has been trying to tell us.